All right, I know a couple of you are still settling in, but it's after 8 o'clock now, so we're going to get started. For those of you I haven't met, I'm Sean Hayes. I'm manager of membership and internal sales here at Automation Alley. Just want to thank everybody for coming out to another Tech Takeover today. A couple things I want to mention before we get started. You should have gotten a survey on your way in. If not, Katie is going to be passing them out to you in a moment here. But make sure you fill those out, give us some feedback, let us know what you thought of the event, and make sure to hand it in on your way out the door. Also, for those of you that are members, we have an event going on tomorrow night. We are going to be doing our spring evening networking at P3 North America in Southfield. Some of you may have been there before. We did a morning member mingle there last fall. Very good turnout. It's a great facility. I'd recommend come checking it out. If you're not a member, be sure to talk to us about how we can get you signed up for that. And with that, I'm going to hand it over to Sean Lowry with Lowry Solutions. He's going to be talking about blockchain and IIoT today.
Great, thank you. Thank you. So I do have to admit up front, I was not the original speaker set for this morning. So our software product manager, Chris Pritchard, was originally due to talk. So today I am the Senior Vice President of Sales and Marketing with Lowry Solutions, so we'll probably get the more macro sales perspective on industrial IoT and blockchain. So, but please, feel free to interrupt. I just assume take questions along as we go. That way we can make sure that we can tailor the presentation to address everyone's open questions and concerns. And so with that, I did have to say from the token icebreaker, I found it interesting, one of our subject matter experts reading the Sunday paper a couple months back found this Dilbert cartoon talking about blockchain, and it kind of, I think, just reinforces the hype and buzz out there that is blockchain when we see it proliferate all the way to the Sunday cartoons. So let's see here. Great, okay. So again, I'm Sean Lowry, Senior Vice President of Sales and Marketing with Lowry Solutions. To give some context to our perspective on today's discussion. So Lowry Solutions, we've been in business for over 40 years. The company started as a computer peripheral and storage company, and ultimately migrated as a value-added reseller in the AIDC space. So barcode technology, and which is now beginning to merge into RFID technology, real-time locating systems, et cetera. So we are located headquartered in Brighton, Michigan. And so we have built the company largely within the background here of the automotive industry, so have a deep expertise within the manufacturing industry, particularly the automotive supply chain. From the company perspective, so we do not manufacture the technology products ourselves. We are a reseller of data collection technology, but we do have a team of professional services, systems engineers for professional services, as well as post-service and support, so break-fix support on technology, offering depot services. And we do some manufacturing ourselves in that we manufacture a line of Paragon labeling. Those are automated print and apply labeling applicators, as well as manufacturing labels. So the consumables going through thermal transfer printer technologies. And our main partners would be like a Zebra or a Honeywell in that space. So why are we talking about the Internet of Things and blockchain today? So sorry, one quick update. One technical challenge. I lost my presentation. Okay, we'll get through it. So why are we talking about the Internet of Things and blockchain today? So today we have working with businesses, right, we're focused on things like inventory management, materials handling, work in process visibility, and those are largely, we see some autonomous automation within that in terms of the data collection and visibility associated with that, but largely we're still deploying systems that are relying upon like mobile computers, mobile barcode scanners. Now I'm going to need some help. Okay. Sorry about that. Do you know if it's going, I can go back to the presentation view of it? I think it's up there. I think it's got to come this way. Not sure if they changed it when they were trying to make it work with the. There we go. Gotta love technology.
Bear with me just a moment.
Sure, sorry. Is it possible to do the display mode where I can still see the notes over here, but it's the presentation up there?
Yeah. Did it switch back? Looks like
Yeah.
it looks like it's doing that for you. Yeah, they're still separate, so your screen.
Okay.
However, I want to do one thing really quick for you. Sorry about this.
Okay.
So that's going to be a problem. Alright, so I can't switch it to anything else. Alright. This guy is still. There we go. Alright, we're just going to have to go with that one. But yeah, you're still,
Okay.
yeah,
That'll work.
your presentation should still be up there. You can launch it. Yeah. So if you just open it up there. And then start the presentation.
Can I use it this way?
Yeah, you can
Okay.
use it however you want.
Perfect.
Good?
Yes, thank you. Sorry about that. All right, sorry everyone. Apologize for that. So, the Industrial Internet of Things, IIoT, and what does it mean for today's business? So really one of the things from an industrial Internet of Things that is the technology that we're looking at to create the connected community. And with that, we have a couple themes that are always necessary to keep in mind in terms of high quality. So what do we mean by high quality? Primarily, we're talking about high quality data. So largely, when we look at leveraging these systems as we move towards Industry 4.0, and we'll talk about that in a second, everything is contingent upon clean and autonomous data and data collection. Two, very collaborative. So one is having the technology platforms in place that enable the collaboration, but two, actually having the relationships established with our trading partners, particularly in the supply chain. And largely today, I'll be talking about mostly the industrial or manufacturing supply chain perspective. Three is quality partners. So today, having our trusted partners, but engaging in them, again, in that collaboration, and making sure that we're also looking at which partners are of the highest quality. So as we continue to look at the progression of these technologies, the trading partners that are collaborating with us in that will ultimately drive the greatest quality, and also we're able to leverage these technologies to make sure that the goods and or value add that they're providing in the supply chain is quality as well. and we talk about the cost value. So, of course, with any technology implementation, we're looking to drive cost, right, out of the supply chain, but making sure that it's also increasing the value at each touch point of the goods or items within the supply chain. And then largely like any technology investment, making sure that we're conscious of the investments that it will require and measuring our ROI along the way as well. So when we look at the industrial Internet of Things, or IoT, as we'll talk about today, and the technologies like blockchain, those are the technologies that we see, and we'll dive into those deeper. But I think the most important thing is that it is in the framework of the Industrial 4.0 concepts. And so when we look at the progression, we talk about it as a progression to IoT, because IoT is enabling this fourth industrial revolution. So you look at over the history, of course, the basic foundation of Industry 1.0, the mechanization of it, the manufacturing process. 2 is where we really look at the mass production. 3 is largely where we're at today, right? So Industry 3.0. We have some automation, we're using computers and electronics, so we have technology in the processes today, particularly at the production side, as well as the supply chain side. But oftentimes where we see the difference between Industry 3.0 and Industry 4.0 is today, there's still a lot of human intervention. And so we are enabling our human resources and our workers to be more efficient with like the use of barcode scanning to maintain inventory records or shipping and receiving, et cetera. But that's still error prone. Anytime we have human intervention, errors can occur, and there's obviously not as efficient as we could. Where Industry 4.0 is the pie in the sky picture that we're looking to drive to, where we can begin to add technology into the supply chain and manufacturing process to create, one, another degree of automation, and 2, having that connected, holistic perspective. So not just having the technology and our systems connected within our own enterprise, but making sure that we have the technology connecting our systems with our suppliers as well. And one other point is, so in terms of, as we started talking about this morning with blockchain and the buzz, some of the other concepts, right, that we talk about is, we see conversations around artificial intelligence and machine learning. And these are all things that are emerging as we begin to move towards the Industry 4.0. Because if we're looking to remove the human intervention and human resources from the systems and from the global supply chain, then we're in turn looking to rely upon computers and data sets to manage those independently. So I went online just to make sure that I was providing a clear context as to the definitions of each two and the difference, because we often hear those two terms specifically used interchangeably, where the artificial intelligence is the idea of machines being able to carry out tasks in a way that we consider smart. So we see this around our lives today in terms of just even looking at our HVAC, right? I mean, so at home, there's a temperature gauge, and when the house gets too warm, air conditioning kicks on. So we're providing, measuring something, and once that response is met, then we're enabling a machine to kick in. Where machine learning is an evolution of that. So it is, when we look at, using the same analogy, so we look at the Nest product at home, right? And what that does is it learns our tendencies around our heating and cooling requirements within the house. So based upon the amount of times that we adjust it, it begins to learn that we want the home to be warmer when we're arriving when we come back home after work around 6 o'clock every day. And over time, it teaches itself that we tend to have the heat go up around 6 o'clock, and therefore it'll just begin to make those adjustments autonomously on our behalf. But again, what I'd reiterate is, so particularly when we look at machine learning, the data is key, right? So these are computer algorithms that need to learn off of the data sets. And so our ability to gather data, clean data, and have that from a technology perspective stored correctly so that the devices and machine learning can access it. So if we're looking at trying to evolve to the Industry 4.0, and we're looking at leveraging the Internet of Things to do that and the technologies associated with that, what are some of the challenges, right? So we look at today, when we're largely working with our customers, a lot of the feedback is twofold. I mean, there's the operational considerations where we're trying to improve efficiencies, leaner, faster, et cetera. And then there's the system of record considerations, right? Making sure that the financials and the ERP requirements are met. So we see a convergence of this operational technology and information technology. And with that, that is really becoming kind of the Internet of Things story. So data security, as obvious, is going to be paramount with that. And so we're going to have more and more systems that are going to be talking with each other and connected to one another and sharing that. And we're going to begin sharing that data more so with our trading partners and other external partners outside of the enterprise. So data security is paramount. We see so many different things in the news today, right? Hackings and breaches, et cetera. So we know that this is an ever-growing challenge. When we look at within the manufacturing environment, so plant control versus visibility. So we have systems in place today, right? Measuring, again, keeping track of inventory, automating shipping and receiving functions, down to the actual, down to the actual plant level, and controlling the manufacturing process, but making sure that we get an operational view is what we hear more and more companies looking to migrate to. So again, we have a lot of this data in the form of a systems of record, but we don't have it in a format or configured in a way that we're able to interact with that data in a real-time basis. So having we hear things of like a single pane of glass. So having software and technology that's providing real-time visibility into the supply chain and the manufacturing process that we can take immediate action on, and then ultimately also might evolve that into like machine learning, so that we can enable these technologies and systems to learn themselves to react and adjust as needed. We know that we talk about millennials and new people coming into the workforce, and that's certainly, the expectation of technology and how we interact with technology is very GUI based, we focus on the ability to quickly interact with data. We all see so much data today with everyone walking around with their smartphone in their pocket. So our ability to create that experience within the manufacturing environment as well is paramount. And then managing innovation. So migrating from an Industry 3.0 to an Industry 4.0 perspective is not something that's going to happen overnight. And any technology investment, particularly at a global enterprise level, is going to be costly. But understanding and taking an approach that if we take a holistic view and understand where we want to get to, and then looking at how we can evolve in various steps along the way, driving ROI, and making sure that we're leveraging the technology investments as we continue to migrate towards an Industry 4.0 framework. So one of my colleagues has affectionately coined the Ohio principle for us of zero human intervention operations. So I alluded to it earlier, and this is largely what the Internet of Things is intended to do. So we have smart machines, we have smart items, and they all are now have a digital voice and are able to interact with one another and able to interact with sensors, et cetera, so that they're providing much more rich data out at the edge, and we'll talk about the edge in a second. But again, to truly leverage all of that technology, then we have to design systems as such that we're removing the human intervention to really gain the automation around the data collection. So I talk about the edge, and what do we mean by the edge? So edge is another term that we'll continue to see more and more popularity around within the IT discussions, and particularly in the Internet of Things. So the edge is anywhere where these smart devices are located, right? So we have that, for instance, if we look at a car manufacturer, right? So they're going to have edge data at their suppliers, so when they're getting notifications and ultimately have visibility into the shipments and receiving of parts and materials that are leaving the suppliers, also the return of packaging, we talked about that. And we need to gather all this data, and the data collection industry itself is progressing so rapidly that the data sets are enormous. So we need to be able to effectively manage that data at the edge, collect all that data, and then serve that up back to business engines and rules engines that can ultimately feed that in the appropriate format to our legacy systems today and to additional operational application systems. So the edge servers, and that is like an emerging technology, right? The way that servers are built and configured to manage this data workload at the edge is something that's ever growing. And that is the key piece, because again, if we're talking about the necessary data integrity that we need, getting clean data, then we're relying on the edge to gather that data and clean that data. And then we're able to, in turn, so mention like locationing. So this is where we begin to like get visibility into it. So if we look at, again, the oversimplified automotive manufacturing model, so understanding the locations of the suppliers and where these assets are at within the supply chain is something that isn't always realized today. And certainly isn't realized in real-time visibility. So taking these Internet of Things devices and gathering that data and providing that back along with location, real-time status, product status are things that are developing today and evolving today. I did want to dive into like a technology example. So here are some pictures of an RTLS indoor environment, so a real-time locating system. Real-time locating systems are leveraging RFID technology, where you see these white buttons in the picture there. So that would be a real-time locating system tag that's going to contain various data sets, and it's going to create that enable that device to be smart, right? So now with that tag on it, we're able to track that, like in this planogram example, amongst the manufacturing floor, the production floor, and leverage that technology to provide us data back. So, of course, location data, but also, again, we can integrate that with sensor data so that we are getting real-time feedback from our legacy production environment. Real-time locating systems is just one example. Within, like I mentioned, shipping and receiving items, so that is often an application where we apply a lot of passive RFID. So a passive RFID would be enabling a UHF tag on a shipment and having, in a typical configuration, readers placed at the dock doors so that we are monitoring the goods and packaging that are coming in and out for shipping verification. So that takes place oftentimes today, right? And even with RFID today. But the Industry 4.0 perspective, right, is actually taking that and not just using that from an audit perspective. Oftentimes today, when we're collecting the data, it's largely to be utilized after the fact. Where when we look at the promise of the Internet of Things and the real-time visibility, that's so that we can, again, connect these systems to make real-time decisions and provide that to our data. So if we look at the final assembly plant, they want to know when their materials that are on order have left their supplier. And they also want to have visibility into that all along the route. So from the transportation perspective, we are working with a new joint venture down in Mexico. And one of the things that they were looking at doing at first was looking at their returnable packaging. So I haven't talked to someone in the automotive supply chain community yet that isn't concerned about the amount of returnable packaging that they're losing and or how they're managing that and the costs associated with that. So what they wanted to do was make sure that they just had an effective and efficient management of the returnable packaging. So we started there by RFID tagging all the returnable packaging so that they can see when their system shows that 50 RTIs have been shipped out, and then they also now have visibility into seeing that 48 of those were received at the supplier. And so one, they're able to handle any sort of disputes going on, and also two, at the end of the day, the supplier still needs 50 RTIs. So they got to figure out a way to quickly and efficiently get them the additional units that they need to continue the flow of goods. And working with them, so that seems like a simple use case, and I guess it is, yet still largely important and has the ramifications of ultimately millions of dollars in returnable packaging over the course of a year or 2 years. But that's just kind of the intro step into how we begin folding in extra visibility and layers of technology. So now we're working with them and working with the suppliers. The suppliers are actually scanning the parts that are going into the returnable packaging, and now they're getting the OEM, the final assembly, is getting real-time visibility into the actual amount of parts that are coming in. And ultimately, what we're looking at doing is adding in GPS along with the transportation providers so that we have over-the-road visibility. In this instance, one of the use cases that they're looking to tackle is the facility, the final assembly plant itself, actually has just a physical constraint of only having 2 inbound lanes. I'm not sure how they built a plant like that from the get-go, but so what they find is that looking at being lean and getting these products just in time, they may have 20 tractor trailers lined up. But the part that they're short on or that they're behind schedule on might be in the 16th trailer in line, which with the normal throughput might take 4 to 6 hours. Well, that 4 to 6 hours could jeopardize production and even possibly look at halting production when the first 13 tractor trailers aren't necessarily, or carrying parts that aren't necessarily as critical. So they're looking at creating a system so that they have real-time visibility into that, so they can expedite which tractor trailers are going to come into and unload first and foremost. Any questions so far? Again, please feel free to jump in or ask. Yes, please. No bad questions. You do, yes. Yep. So again, so if we kind of dive into this example a little bit, and I can tell you specifically what we're doing. So today, the kind of crawl, walk, run perspective, right, is that we have created a zero human intervention system at the final assembly. So at all of their dock doors, we have RFID readers that are automatically scanning and reading the packaging as they're being unloaded and being shipped back out. But they needed the suppliers to be involved as well. So, but at this stage, it was difficult for them to mandate the investment into the technology for the suppliers. So what we're actually doing is, again, kind of leveraging some of the Industry 3.0 technology of it, and they've created a process using just a handheld RFID reader for each of the suppliers so that they're manually scanning. Now, RFID versus barcode still gives you some efficiencies. You don't have to scan every one. You're able to scan kind of the entire packaging or shipment all within seconds versus having to go and scan each barcode. So they have an application that is connected to the OEM's back-end system as well. So they're going through scanning that. The OEM now has visibility into which of the RTIs, the returnable packaging, is going to be coming to them, and that's where the process is at today. Now they're just beginning to use that same manual scanning process, again, still leveraging RFID, to scan the parts that are in the containers so that they're getting the actual part material visibility. But ultimately, and we've been engaged in the conversations, so now the suppliers are looking at it saying, well, we want to leverage the technology as well, provides them an opportunity to make similar technology investments, create a Ohio zero human operation on their side so that we can begin to truly connect that. And then ultimately, those are the types of, that's the type of architecture that we will need to leverage blockchain, which we'll talk about here in a moment. So again, there's various items at the edge, right? So one of the other things too is that if we're talking about the supply chain example there, but also if we look at even the production floor, the production environment, we're talking about also having smart machines and production equipment, tooling, et cetera, so that we're able to more efficiently manage those and gain real-time visibility within the production environment. And when we look at the items themselves, this is where we start talking about blockchain. So a blockchain, it's a data technology that is going to be associated with each of the items. So it is they call it a ledger, and that ledger will contain information about each of the items. And we'll dive into that in more detail shortly. So just kind of there's a bit of a summary of considerations when we're looking at Industry 4.0. We refer to it as AIDC, but you have your data collection technology, your IoT devices that are out there collecting and generating this data. You have your information integrity, so largely your legacy systems, right, that you're operating today around material planning, financials, warehouse management, inventory, supply chain execution. We have the information security, so how we're protecting all this data and what data we are or not able to share, largely are not able to share today. And in the middle of all that is where we are going to look at leveraging technology like blockchain to create the collaboration. So blockchain and the digital transformation. Again, from the cartoon, lots of hype around blockchain. Really, what you'll always find is that, so blockchain is a ledger, and it's the data layer, and what we're doing is, if you think of it as any ledger, and they're very specific with the ledger because in a way it's like a public database, like a decentralized database, but the difference from a database versus a ledger perspective is that we're trying to maintain integrity. So instead of overwriting a record, as often done within a database, we're actually just adding an entry to the ledger. And why is this important? One, it's important for data integrity, and two, so that we also are able to create and look back at the particular edge items and understand everything that's going on with those. So if I take a, let me see here. No, stay here real quick. So the ledger concept, it's a bit much to grasp, but again, let me refer to the automotive manufacturing example that we were talking about. So, and we're having discussions about looking at a blockchain. So if we take the blockchain data technology, and it's going to be shared amongst trading partners. So one, again, as I alluded to in the beginning, it's important and critical that we have collaboration. So while a blockchain is not necessarily owned by one participant, someone is going to define how the blockchain is used and how the active members of that blockchain, what their roles and responsibilities are. Go ahead.
So who overall controls the database or the ledger? Where does that reside?
So you're saying like physically, it's decentralized across the network, similar.
So like this, every entity that's utilizing it, like download it and have a copy of it that they're working off of, or is it a location where they're all every kind of?
So good question. So they're very specifically not downloading it and working off a copy. So if we look at, and this is evolving, one thing that I do want to explain too, from a systems integrator perspective, which we are, blockchain it's an open source technology, right? So I'll talk about some of the roots in a little bit. But it's an open source technology that is quickly and rapidly reaching a product state, right? So as we have the mega technology companies like IBM and Microsoft, et cetera, beginning to take the open source blockchain underlying technologies, and there's like IBM, for instance, uses Hyperledger. If you read about Hyperledger, that will be often associated with IBM. So they are working through how to productize that for us to ultimately connect our systems. So if we have a Internet of Things system where we're collecting data and doing operational processes with it, that is going to feed updates to the blockchain. And again, the blockchain it's open source technologies that we're leveraging. So kind of like almost in a way of like similar to the internet, right, being decentralized.
So in the same way, nobody really owns the data, people are just contributing and adding to the data.
Correct. Yes. people are adding and contributing to the, which is the fundamental principle is that it is transparent in that no one owns the data, right? So no one owns the data, no one can manipulate the data. But if you look at it logically, there has to be an instance of, someone has to take ownership of it, right? So if I use my final assembly perspective or example, the OEM, this joint venture that we're working at, they're exploring engaging their partners in a supply chain, in a blockchain. And keep in mind, there will be multiple blockchains. So even one final assembly plant might have multiple blockchains that exist. And that's important because it's not just a global thing, because what we do is if you take the blockchain and the OEM is kind of setting up the blockchain, right? They're determining which people need, which of their suppliers need what rights and what the requirements are of them to do that. So maybe in a micro example, one supplier is manufacturing a very important part that has multiple QA checks. Well, the OEM is going to want to know that that part has gone through those QA checks, right, from a quality assurance perspective. So that supplier is going to have access to the blockchain, and it's all cryptocurrency encoded, in that they are going to be required to update the record for that specific item. So it's going down to a serialized item, right? Making sure that they're saying it's past QA 1, 2, 3. So that will be associated with that item's record on the ledger in the blockchain. So again, and then it won't get overwritten, it'll just be added to. So the next requirement for that supplier might be to update the blockchain ledger and say that that item has been shipped and time-stamped and associated with X order from the OEM. Does that make sense? Sure.
So, and maybe this is a naive perspective, but the idea that there are going to be multiple blockchains, how do you define the scope? What will fall into one particular end-use product? Would it be a system?
Good question. So what we see kind of the evolving conversations around is, so within one particular, whatever closed loop that we need to establish, right? So in terms of that may expand down to an end user. A good example also is within the food manufacturing industry, right? So we hear a lot about farm to fork and organic and such. There's actually a great, if you Google Microsoft blockchain, you'll go to their blockchain Azure page, and they have a download brief for supply chain applications. And they will dive into this food example. So if we look at that, where, again, we have the grower or farmer, and they're under strict mandates, following strict rules to be certified organic, non-GMO, et cetera, even down to particular labeling. So they're going to be responsible to update the blockchain ledger with their regulated practices to make sure that that is defined. And then they're going to send that along, again, when they're, part of it is when they're shipping it up through the supply chain, they're going to be updating the ledger. That might go to a wholesaler of some sort or a distribution facility. They would be updating the ledger to say that it's been received. And then they would forward it on to let's say a retailer, right? So they're going to be updating the ledger that they've shipped it to the retailer. The retailer would have visibility into this. They would also have, maybe it's defined because it's organic, that all the trading partners need to see the steps and the updates in the ledger that qualifies it as organic. And then ultimately it goes through the retailer, and even the end user. So when you talk about how broad or how big it could be, like we could have the systems enabled down to end user visibility, where they might have a website that they go in, log into, and they see this data exposed and formatted in a way that means something to them, but that we're tracking it through there. Now, building upon that example and looking at the IoT side of things, so when we look at the Internet of Things, so within the food manufacturing, that it might be required that we want to look at making sure that that food, if we're looking at perishable food, is in the proper climate-controlled environment all along those steps of the supply chain. So with the packaging, we may have a sensor that's monitoring humidity and temperature. And so that sensor connected to some sort of RFID tag is able to monitor the environmental considerations. The RFID tag is going to collect that and send that data up. And ultimately, we're making autonomous updates to the blockchain ledger with that data, so that if the technology is in place, all along the process, that blockchain is growing, that blockchain ledger is growing and growing and growing with more data, so that we can validate, or maybe the retailer can validate, that this product has been within the right humidity and temperature controlled environment, because that's directly tied to the amount of shelf life that they're going to have on the product when they receive it. So, and ultimately, like, look at pharmaceuticals. Pharmaceutical manufacturing is another big one, where they are making large strides and investments into real-time temperature sensing and environmental sensing, because it certainly directly impacts the viability of the product. Any other questions? Please.
So let's look at the RFID sensors that they're capturing data and they're sending to the blockchain. Is the ERP or MRP application tracking the data for the blockchain, or is RFID sending the data in the past?
Good question. So what we see is that, especially early on, right, when we take legacy systems into consideration, like the ERP, that the RFID is collecting the data and sending it to an IoT data layer, an IoT layer. And so from that IoT layer, we are then sending that information up to the systems of record. So there's an additional technology layer in there, because we have to collect the data. We also have to manage all the devices, right? Not to just gloss over the fact that these are devices that we need to manage and monitor in real time. So that IoT software layer, and I'll talk about some IoT software in a moment, is going to manage the devices, collect the data. It's going to update the blockchain, and then it's also going to update the legacy systems. Does that make sense? Does that answer your question? Okay. All right. So we're largely focused, Lowry Solutions, largely focused on the manufacturing, supply chain, transportation, logistics environment. So we are really looking at the industrial Internet of Things, different than what might be the home Internet of Things that we see emerging, et cetera, et cetera. But one of the research firms, Aberdeen Group, we can see that, as I was talking about earlier, some of the themes, right? I mean, reducing cost within the supply chain is obviously the largest growing concern that we're looking at. But also the improving operational equipment uptime and availability. So this is something that we see really emerging as well. Because again, the manufacturing equipment itself is becoming smarter and smarter, is more technology advanced, and/or there are systems now that can integrate with those types of systems to enable them and make them smart. So the efficient use of the assets and things like preventative maintenance, et cetera, again, going back to leveraging sensor technology and such. Improve product quality and safety. Yes, please.
So coming from the event industry,
Mm-hmm.
I see this as a great use to location events, festivals, or to your point, flags, seasonal, real live data from phones, people movement.
Mm-hmm.
What area is being attacked by people who want to eat?
Mm-hmm.
Food can get there, actually people who work there. So do you know, are they using it?
That's a good question. So I'm not totally familiar with a lot of the applications within hospitality or service industry with it, to be honest. But I can comment. I mean, it just strikes up the thought, that I made in preparation. So we're seeing that information used, right? And when we look at, you're talking about phones and things like that, I found it so bizarre on my iPhone after whichever update happened, where all of a sudden now I get in the car every morning and it tells me how long it's going to take me to get to work, right? So we see these things learning and happening, and then sadly enough, it also, if I get in the car around noon at the office, it'll tell me how long it's going to take me to get to one of my favorite lunch spots, whether I'm going there or not. But to your point of, having again, collecting, when we talked about the edge earlier, right, that's really phones being an edge device, collecting location data or whatever other data and beginning to leverage that, we're seeing emerging applications for that.
You could then do an app. So I go to Walt Disney World and I'm hungry, I can open an app and find out what the wait time is to take an app.
So, yes, agreed. And we're seeing some of that, again, I think without even realizing that, or actually without it being positioned as trying to monetize that. My wife and I on Saturday went down to Detroit to a restaurant for dinner. And we had to look up the directions, and looking it up in Google Maps, it also told us that the restaurant was very busy. Don't know, I mean, kind of presumably, right, piecing the dots together, understanding how many people might have traveled to that location or something. We got there and it was 30 to 45-minute wait time. So, it just presenting that data and knowing that data, again, is an interesting take. So this one's, I apologize, a little small and I can't zoom in, but I'd be happy to share these slides as well afterwards if anyone would like to receive a digital copy of them. But when we see the acceleration around IoT, and we talked about racing towards the competitive edge, discrete manufacturing and transportation logistics, while maybe historically being a bit of a laggard in technology adoption, we actually see a greatest amount of interest in, again, achieving that next industrial revolution and beginning to leverage these technologies. Again, I apologize for the eye chart, but this is just kind of a graphic to show what this connected factory in action would look like. Let's skip over that. So diving into the blockchain technology itself a little bit more, I think everyone, when we hear about blockchain, we kind of instantly think of Bitcoin. They're largely tied together. That's because, so Bitcoin leveraged blockchain open source technology to create their version of the financial transaction. So we talked about the differences of a blockchain versus databases in supply chain. So the one thing, the problem with the database is that someone has to own it and someone has to maintain it, and therefore there's going to be dependencies and areas where that can fail. Also, things can be deleted from a database. So the data integrity is, and visibility, transparency is one of the paramount aspects of leveraging a blockchain. So it's the one thing, again, being decentralized, it's not just peer-to-peer. It leverages and it maintains that data layer for the connected supply chain, so the connected ecosystem. So you're able to have multiple trading partners interacting with it. You're able to determine which people have visibility to which information. And one of the things that I didn't touch upon earlier is the contract, the concept of a smart contract. So the smart contract, again, if I go back to the OEM example with the suppliers, is that so blockchain, leveraging the concept that Bitcoin implemented, it is largely looking at achieving financial automation as well. So in automotive OEM example, right, the concept is that if we have clean data and the supplier is shipping out 50 parts, when those parts are shipped, then they, in theory, that record gets added to the blockchain ledger, and then they could be automatically paid from the OEM, or if there's a distribution wholesaler involved in it, depending upon what the supply chain looks like. So the idea of a smart contract is taking this connected supply chain, again, and actually applying the financial payment terms of that. So, and also, like on the other side, we're able to look at leveraging it for penalties as well. So if a supplier is required to ship out 50 widgets within 24 hours, and that shipment goes out at 36 hours, then the automated technology is going to read that transaction, update that transaction to the blockchain ledger, and they could automatically be assessed a penalty or a fine because of that. So there are some, I don't know that I'd say downsides, but limitations of blockchain today. This is kind of a high-level overview of them. But one thing also, though, is that there's speed and performance considerations. So I mentioned earlier that a lot of the large global IT companies like an IBM or a Microsoft are beginning to productize this technology more. That's largely around the efficiency of the technology itself. So when we look at the technology that Bitcoin used per se, it's very slow. It doesn't actually keep up. So the amount of time that it takes to update that ledger, it's meaningful, and therefore it's not able to keep up with the pace of supply chain. So IBM and Microsoft are examples of companies that they're applying additional technology on top of the blockchain open source technology to make that more of a, well, to productize it, to enable it to actually be applied within business today. And this just references, again, the connected nature, not one-to-one, but within and around the community that's of all the suppliers that are involved within the blockchain. Again, faster, cheaper, because no centralized person is maintaining that. They're all just accessing that and updating the network and the blockchain ledger over that network, and they're able to make sure that it goes direct. I'm not sure if you can make that out or not, but this would be trying to visualize what a blockchain ledger would look like, right? So within that, it just is passing along concepts. So block 1, 2, 3 is going to be a particular item, right? So it's going to be an actual, in the one example earlier, the actual part itself. So as that part is being created, we are going to take maybe timestamp data, quality assurance data, shipping data, receiving data, and taking all that data along with potentially sensor data from the Internet of Things and updating that information to its block within the ledger so that we have the historical consideration for it. It's kind of a difficult concept to wrap your head around a little bit. Is there any questions? Please.
I have a question on the security part.
Yes.
Now, is it subject to the same risks as the regular internet?
Good question. So asking about the security. So I'm going to be careful here because this is where I wish the technical gentleman from our organization was here to talk about it. But largely speaking, so there's a key and token system. So the blockchain is encrypted, and each supplier has a key. And that, they basically, I mean, using a physical example, right? They are going to insert their key into the blockchain so that they are allowed to make that key will determine a couple things. One, it'll determine what data they have access to in the blockchain or on the blockchain. So they may not need to see some other supplier's data if this is a blockchain set up and optimized for the OEM or final parts assembly. So from a data security perspective, they're only going to be allowed to see what information that there is determined up front. And then two, again, there is technical levels of encryption that I couldn't really speak to, but there we go. But the key and token system is what's determining and driving the data security around it. Any other questions so far? I promise we're coming up on the end here. So talking about some of the reasons why we look at applying blockchain in the industrial Internet of Things. Again, it's really the data layer, right? So now we have a technology that is almost universal in the fact that it's decentralized, that we're able to have multiple trading partners leverage and to create more accurate data. And so from a perspective, from our company's perspective, so Scenaria is a software company that we launched as the question you had asked earlier, for the Internet of Things software. So Scenaria is a software product that we have. And if we look at the architecture, it's a hybrid cloud. And what does hybrid cloud mean? So in IoT, I talked about the edge, and the edge is the critical component. So in this example, we're looking at the devices. The devices themselves are going to be at multiple sites. They're going to be different types of devices, different types of readers, like I mentioned our TLS technology earlier, RFID technology. Those are all collecting data, and they are sending that to the edge server. So then the edge server is processing that data, formatting it away, and determining based upon workflows what data needs to be sent up to, in this example, when we talk about the Scenaria cloud, those would be applications like asset tracking or work in process, but that could also be a legacy system like an MRP or an ERP. Please.
Many of us are having sometimes a struggle to kind of sort out the blockchain, I'll call it the physical architecture. This gentleman's question around, you know, who owns the data? Is there a master server? Is distributed? It's clearly a distributed model.
Yes.
In your scenario product that you've launched,
Mm-hmm.
can I assume the highest level cloud layer, scenario cloud, is the one that's contributing and communicating on the blockchain network, not those layers below it?
Let me jump ahead here. So it's going to probably be at the edge. At the edge level. So if we talk about our scenario architecture specifically, so at the edge, we are managing the devices, we are collecting the data from them, we are processing those through a business rules engine. So within the software, we are creating the business rules saying, if this, then that, right? And as part of that, as part of one of the business rules, it says, would be, oversimplifying, if shipment is 36 hours, not 24 hours, update blockchain ledger and send that information to the blockchain ledger.
And to piggyback the question, if my manufacturing firm wants to license your scenario technology, and I also want that asset movement data to go to my legacy ERP, be it SAP, Oracle, whatever, is that also coming from the edge level, or would I normally take that data movement information from the scenario cloud level and then update my legacy, my ERP?
The edge layer.
Again, the edge layer.
The edge layer would update the
APIs.
Correct.
For scenario at that level.
Correct.
Like those APIs or
Oracle, R12, for instance, et cetera, you know, SAP. And similarly, the blockchain is, again, oversimplified a little bit, but it is basically the edge is through an API to the blockchain technology. There's a lot of servers. Correct. Correct. So not totally dissimilar than the cloud models today, right? And like even if I just use our software as an example, right? Part of the cost of goods with that software is if we're utilizing one of the applications, kind of the pre-built suites that we offer, we built ours on Microsoft technology. So there's Microsoft Azure is their technology, is their cloud technology, and there's a license or there's a data fee, if you will. So this much money gets you this much data in the cloud. You go beyond that, then you pay more money. Yep, and the servers at the edge, right? Because now we're collecting so much data all around with all these different objects, and we have to process that. There's a large dependency upon server technology and integration of the servers. This is just redundant on the Ohio principle we talked about earlier. So last couple slides here, just a couple different use cases looking at. So this is somewhat similar to the example I was alluding to earlier, but definitely in the aerospace industry, right? There's tremendous amount of regulation on quality assurance, parts verification, authenticity, et cetera. So again, in this instance where we're really would be leveraging the blockchain layer, that data layer, to be the source of truth of the journey that part has gone through. So through the manufacturing process and through the supply chain process.
This is an example in reality. This isn't a hyper. This is not an imagined solution. This is in place. This case study.
No, I'm sorry. This is not, this is an example of what could be. Yes, this is an example of what could be. This is not a specific aerospace manufacturer. So to answer your question, or the underlying question, I think, of where are we seeing this today? It's limited in its use today. And that's one of the things I wanted to make sure that I touched upon, because so when we're out looking and involved with different industry action groups, et cetera, industry organizations, blockchain is certainly an emerging concept, but again, there's so much that requires, there's so much being required to enable it, in that largely we have to collaborate with multiple trading partners. That in and of itself has been tried. It's been tried in our own industry early on with RFID, where Walmart was told all their suppliers, they kind of almost tried to create a blockchain in their own way. You will tag all the items that are coming to us, and you'll update our database that we're maintaining. And there was a lot of pushback and incurred costs. So the one thing that I want to bring up with the blockchain and the fact that when we go out today and we see a lot of largely pilot programs that are taking place, a lot of the pilot programs are based around the concepts of the smart contract perspective, actually. That's what we're looking to automate is early on, is more so the financial aspect of it. But the thing about, so as the IBMs and Microsofts of the world continue to mature this blockchain technology, we're not that far away from it truly being in a production, sustainable, and scalable space. We have to look at all the prerequisites that go into that. And that is, one, having the IoT systems like we were talking about in the examples in place today, where we're collecting the data. Because all of a sudden, if we just remember that the blockchain is just the data layer, we have to have all the data collection systems and processes implemented to feed that data layer. And so there's, of course, adoption and technology life cycles that go in with that as well. And then looking at, again, the collaboration of it. So we see a tremendous amount of interest in the end user and manufacturing community, particularly in the automotive community today. And they are engaging in conversations. I mean, largely we see people with Internet of Things task teams, if you will, established internally, and people beginning to take on core focus within that area and reaching out to their trading partners. But it's a process, right? I mean, this is, if we look at the earlier slide, the Industrial Revolution, you're talking 40, 50 years going from one stage to another. And when we look at this, while we certainly see rapid maturity of technology in our world today, so it won't be 50 years from now, but it certainly will be years, not months, that we're creating fully integrated blockchains. This would be a logistics example, which I think, again, we kind of touched on as well. One of the things that we didn't touch on so much would be warranty. So this is one interesting area. We partner with Siemens. They have an Internet of Things software platform called MindSphere. They're doing a lot of interesting things with that, where one of the things that they look at is, so they're beginning to use the Internet of Things software so that they can monitor the conditions that the machinery is being used under. So they're essentially warranties on these machines, but it is presuming that this machine will not be operated beyond X pressure, beyond X workload. And so with the sensor technologies available today, they're monitoring that, they're reporting that, they're pulling that data off into their MindSphere Internet of Things software, and they're able to create applications that say, well, in this end user, you're asking us for a warranty claim. However, this machinery was specified to operate within these particular parameters, but it's exceeded that, so they're able to actually begin quickly and effectively doing some cost recovery. And with that, that would be kind of it. Again, it's a, I will say that it's a somewhat difficult technology at first to kind of wrap your head around, and I think that that is partly due to the fact that it's an emerging technology, so it's not a very, you know, everyone has their own spin on it and their applications and use cases for it. When you go look at additional research on the internet and pilots and things of that nature, one of the main ones is the stock market. So we're actually just looking at the financial transactions and the speed of which those transactions are taking place. So truly interesting technology, one that will definitely be leveraged within the emerging Industry 4.0. And is there any other questions that I could address? Please.
Yeah, one more follow-up question. So the prerequisite really is having the existing infrastructure for IoT. Has to be ways to scan and collect that data. What are the first steps? You mentioned a smart contract. Would that be a good kind of first step for a company to be able to choose that blockchain?
So one of the first steps that we would recommend is understanding what the different data points are that are going to be touched and pulled that this blockchain is going to sit on top of. So if the blockchain is sitting on top as a data layer, and we look at whether it's additional locations, facilities, separate suppliers, et cetera, and mapping out, okay, we have to centralize all that information, right? And so that we have the ability to get holistic data that we can report up to the blockchain. So it's really an exercise in system architecture of what are going to be, of course, because of legacy system considerations, what are going to be the systems that we need to map to have the ability to interact and report back to the blockchain. Yes, please.
That's your wrap-up time. My selfish reason being today was less so about Industry 4.0 in the plant, more about the blockchain interest. I'm from Lowry Solutions in Ann Arbor. We build software. We just engaged in a new project, not manufacturing. It's going to use blockchain. I'm not the architect. I'm the account executive, so I want to know a little more deeply about the technology, like you do, young lady, about event management. My clients can use blockchain to manage assets, graphical assets, that I've got implemented on a web server, and all the participants, which are the nodes, you had nodes.
Yeah, right.
All the nodes are social users with one of these, with an app on it that we're going to build. So they're all nodes, I get it, but they aren't controlling nodes, they're participant nodes. My web server's got to be, there's going to be a controller. This isn't a free-for-all. Someone's got to be in charge here, right? Unless I got this wrong, my web server app's going to be in charge of setting up the blockchain, right? So my curiosity is very much about blockchain, a little less so about Industry 4.0 in this current example. You can't miss the headline on June 20th, more blockchains coming. RSM, another participant, automation member will be here, more from the consulting side, because that's what they do. They're a CPA firm. They're all about the money,
Right.
I think. Okay? I probably will show up for that one too, because what a great way to learn, right? I'm not designing this solution here today. I'm just milk off your knowledge from Lowery,
Sure.
right? Why not? So, yeah, blockchain's very new. We get involved from Bitcoin. It's going to be hot stuff. You know, the young guy that engaged us, it's the startup thing. VC funded. He's less than half my age. Okay? He's all about blockchain. So if you guys are interested to learn more about blockchain, I'll teach it for automation alley. On the 20th, there'll be more of it here.
It's great.
You might want to think about connecting with RSM.
Yeah, absolutely. No, we're definitely going to follow up with them.
You've got all the implementation technology that
Right.
they're all more theoretical at RSM because they're consulting.
No, that would be great. We'll definitely have to make sure we participate with them as well. So, yeah, it's and again, it's happening today, right? I mean, it isn't. I don't think that it is widespread adoption today, but the technology is there, and so with the right planning and execution, able to effectively leverage it. Any other questions? All right, well, thank you all very much for your time. Appreciate everyone waking up early with us today. So hopefully I didn't put anybody back to sleep. No, we even got some questions, so thank you for the participation.